we're going to have a look at using electrical circuit calculations. And when approaching these questions, you always want to think of two different ideas, either using any equations that come to mind. So there's lots of equations given to you in an exam. There's V equals IR, P equals IV. There's two more equations of power given to you, which are I squared R and V squared over R. There's an equation relating energy to power and time, an equation linking charge to current and time, so on and so forth. You may also have to use the idea that in series, the total resistance is just the sum of the individual resistors, which we actually will have to in this question. Whereas in parallel, 1 over the total resistance is 1 over the first resistor plus 1 over the second resistor, so on and so forth for however many resistors are in parallel. Or you have to use that idea of how current and voltage are distributed in series and parallel. So how I used to remember this was I used to draw my own little table in an exam, and I used to remember that current actually is always the same in series. So if two components are in series, the current across them is always the same, whereas in parallel it's the opposite. Current is split up. In series the voltage is split up, and in parallel the voltage stays the same. I used to remember this part of the table and fill in everything else as being the opposite. So it's giving you a circuit here where W and X are in series. The combination of W and X is in parallel with Y, and then Z is in series with this whole junction on the left here. The EMF, which is the total voltage that's supplied by the battery, is 10 volts, and the reading on the ammeter, so the current that flows through the whole battery, is 2 amps. Calculate the total resistance of the circuit. There's one more question here, and we can actually just use one of the equations to do this because we know the total voltage through the circuit, and we also know the total current flowing through the circuit. The equation linking voltage, current, and resistance is V equals IR. We rearrange this to make resistance the subject, so V over I equals R. So it's the voltage of 10 divided by the current of 2 amps, which will give you a resistance of 5 ohms. That's the answer to this question. Part 2 tells you that W, X, Y, and Z all have the same resistance. Let's get the highlighter tool out. Show that your answer to part A, which is that the total resistance is 5 ohms, is consistent with each resistor being 3 ohms. So what this is asking you in a fancy way is basically show that when each of these resistors is 3 ohms, the total circuit resistance is actually 5 ohms like you calculated. So let's have a go at doing that. We're going to use these two formulas here. Oops. Total resistance in series and in parallel. Let me just get the pen tool out. To start with, so these are all 3 ohms, so let's label that. Since W and X are in series, we can find the resistance of the combination of them by adding them together. So let's write that first. W and X is 3 plus 3, so 6 ohms. But then do you remember I mentioned before the combination of W and X is in parallel with Y? That means that to find the total resistance of this parallel junction, we have to use this formula here. So we say 1 over the resistance of the parallel combination is 1 over the resistance of the whole top of the junction, which we've found is 3 plus 3, so 6, plus 1 over the resistance of the bottom of the junction, 3. That will just equal 1 over 2, meaning that the total resistance of this parallel combination, sorry, don't know what happened there, this whole thing here is 2 ohms. Now I also mentioned before that this whole junction on the left is in series with this junction on the right. In series, we know we find the resistance by just adding up the components that are in series. So we just do this whole component on the left of 2 ohms, add this component on the right of 3 ohms, and that will get you to a total resistance of 5 ohms. So that's how you do A part 2. Now B part I, this is where it gets quite a bit more difficult. Just going to erase some things here. Okay, let's change the pen color again. So it's asking for the current through resistor Y. So we know the current flowing through the battery and into this junction is 2 amps. But we also know that because it's a parallel sort of junction, the current is split up. Now, how is it split up? Here's you have to be very careful, because in the top of the junction is 6 ohms, whereas on the bottom of the junction is 3 ohms. So the current, it doesn't just split up evenly. Because we know current is inversely proportional to resistance, that means wherever there's 2 times more resistance, there'll be 2 times less current. Sorry about that. I'm using a new trackpad, by the way, so my writing might be awful. Sorry about that. But why I say that is, that means that because there's 6 ohms at the top of the junction, that's 2 times more than the resistance on the bottom of the junction. So that means that 2 times less current will flow through the top. So we split up the current into 3 parts, 2/3 amps. And like I mentioned before, because there's 2 times more resistance at the top, there's 2 times less current. So 2/3 will flow through the top, and 4/3 amps will flow through the bottom. So through resistor Y, there's 4/3 amps. Lastly, for this part of the question, so we mentioned that going through the top of the junction is 2/3 amps. And since we individually now know the resistance through resistor W and the current through resistor W, we can find the voltage through resistor W using V equals IR. And we say it's the current of 2/3 that flows through it times the resistance of 3 ohms, which is 2 volts. And that's the answer to the question. That was very difficult, but it's always a puzzle with these questions. You're always either going to use the equations or what you know about current and voltage in series and parallel. There is always a solution using those methods. Thanks for watching, and if you have any questions, please let me know in the comments.